Hello everyone, welcome to my channel. I hope you have seen the previous video. This is continuation of the previous video. So now we are seeing how to graphically represent the pushdown automata. That is graphical representation of PDA. So remember that every PDA will be having the states. The states of a PDA always correspond to the nodes in a graph, and the states of the PDA are represented with the symbols circles like this, like a DFA. And the final state in the PDA is represented with two concentric circles. This is the form to represent the final state. And the starting state of the PDA is always denoted by the arrow mark, as we have seen in DFSL. The starting state is indicated by the arrow mark. And if there is a transition of the form, transition of P comma A comma Z equal to Q alpha. If the transition is in this form, then there will be an arc from state P to state Q, and the arc is labeled as A comma Z bar, okay, forward slash followed by alpha, that is A comma Z. That is when the input to be scanned and top of the stack is Z, and the symbol you may push the input symbol to the stack. So here initially it was Z, and now we are pushing the input symbol A to the stack. So initially there was Z in the stack, and now we are putting A to the stack. So this AZ, whatever the content is there, that is called as alpha. So how do we write it in the graph? A comma Z followed by or. So this is forward slash followed by alpha. Alpha is the symbol on top of the stack. So how do we represent this? From the state P, on reading A, when top of the stack is Z, you are pushing the symbol A to the stack. Alpha is nothing but AZ. Okay. So here it is moving to the state Q. So this is the graphical representation for each and every arrow. By consuming some input and seeing the content of the stack, it is moving from one state to the another state. So here it is changing its state, as well as what is the result? It is changing the state as well as the contents of the stack also is getting changed based like either it is performing push or it may be performing the pop operation. So this is about the graphical representation of the PDA. So next we are going to discuss about the acceptance of a language by the PDA. Hope you have understood this. The next basic fundamentals which you should know in PDA in order to solve some of the problems is the language acceptance by the PDA. That is acceptance of a language by PDA. So the PDA can accept the language by two methods. One is it can accept the language by an empty stack. So if it is accepting the language by an empty stack means, then we write L of M, language of the machine, is equal to W, where Q0, W, Z0 derives, moves to some final state P, epsilon, epsilon. So this is how we write for W belongs to summation star and Q0, P belongs to Q. Okay, this is one method by an empty stack. The other method is language accepted by the PDA by a final state method. The other one is by the final state method, starting from the final state. So that is M equal to language of the machine M is equal to W, where Q0, W, Z0 derives some derivation here. Okay, it derives P, epsilon, alpha. And where here alpha belongs to what? Alpha belongs to gamma star, P belongs to final state, and W belongs to what? Summation star. So the meaning of this is The language, acceptance of a language by the PDA. It can accept a language by an empty stack, or it can accept a language by a final state method. It means the last transition how we should write for the language acceptance, for the string acceptance or rejection. So if you are writing by an empty stack means, assume that L of m equal to some string w, where from the starting state q0 comma w, it is scanning some input symbols from the string, and initially top of the stack is what? Z0. From Q0 on consuming some input, when content of the stack is Z0, it is moving to the final state P. And the string last configuration should be what? It should move to some final state P, and the string should be completely consumed. It has become null. So it means, suppose if this is my string, here I have null epsilon. If I reach the epsilon means I have reached the end of the string. So this should be null, and content of the stack also should be empty. So it is by an empty stack means the last transition here, the last transition what I should write, it should be epsilon by an empty stack. Stack content should become null. If this is null, that is if it is epsilon, then we say that the language is accepted by the empty stack. Okay guys, so here W belongs to what? Summation star. Q0 is the starting state and P is our final state. Both belongs to what? Q itself, the set of states in the PDA. Similarly, so this is the rule I should follow. If it is an empty stack, my last transition should be always like this. My last configuration of the transition function. Suppose if it is by final state, then how to write the configuration? L of m equal to W, where Q0 comma W comma Z0 derives, see here, the configuration symbol. It derives what? P comma epsilon comma alpha. See, you should be careful here guys. So it means that from the starting state Q0 on consuming some input, when top of the stack is Z0, so it might be perform push or pop operation, but the last configuration what I should write is when it has reached epsilon, that is when there is no input to scan, that it has reached the end of the string, it is moving to final state from Q0 to P. Q0 to P, it is moving to the final state. And alpha means here stack need not be null because it is acceptance of a language by final state. So the stack content here alpha, this stack content should not be null. There should be some symbol. It might be Z0 or A or something should be there, but stack might not be null. So it means that it is acceptance of a language by PDA using the final state method. Whenever you write the stack symbol as null, it is by acceptance of a language by an empty stack. When there is some symbol on top of the stack, it is not null. It is moving to final state, but the string to be scanned is null. When the input string becomes null, content of the stack is not null. Such a configuration, such a language is called acceptance of a language by the final state method. Okay guys, so these two are very important whenever you are writing the transitions for pushdown automata. You have to see whether it is by an empty stack or whether by a final state. Accordingly, you have to change these two transitions. Hope you have understood. Please don't forget to subscribe, like, share and comment. Thank you.